everyone, and welcome back. I wanted to make a few short videos that are directly related to our current topic, which is circular motion. They're small, but distinct enough to where I wanted to separate them from what we were recently doing. And in fact, I'm going to put this centripetal force equation in the lower left-hand corner here, which is what we've been working with, so I could reference it. So this video is about circular frequency and period. These are terms that come up a lot in circular motion. So in other words, instead of asking about the velocity of the object going the circular path, you may be given or maybe asked for what is the frequency of rotation for the system that is actually spinning. So let's start with a few definitions. Frequency, which is a word you've probably heard before. The number of oscillations, rotations, or vibrations over a period of time. Symbol looks like an italicized F, and in this particular case, you are dealing with rotations. So that means frequency unit, in this case, will be rotations per second, and that idea is going to be pretty important. Side note, this unit has an abbreviation called Hertz, usually abbreviated Hz. So if you are told a record player is spinning with a circular frequency of 10 Hertz, it's spinning at 10 rotations per second. Now, period is the amount of time it takes for one rotation, so its unit will be in seconds. Now, how does that relate to our centripetal equation here? Well, if an object is moving in a circular path, how far it is from the center and how quickly the object is spinning is directly related to its actual velocity. So let's break this down. I have velocity, or velocity tangential, which has the units meters per second. Now, keep in mind, we're talking about a circle here. And if you're moving around a circular path, when I'm talking meters, I'm talking about the circumference. And circumference is 2 pi times the radius. So velocity can be written as the distance taken around the circumference and how much time that is in. And we just said the time to go around once is known as the period, which means velocity can be written as 2 pi r over period. I'm going to write that over here. So I'm going to put this here and mention one more thing. If frequency is rotations per second and period is the amount of time for one rotation, if I take 1 divided by frequency, that would give me seconds per rotation. And this would be period. That means period is 1 over frequency, or frequency is 1 over period. It can be written either way. They are inversely proportional to each other. So how do these relate? If you are given the frequency, you can get the period. Once you have the period, you can get the velocity. Once you have the velocity, you can then start using the centripetal force equation. Or it could be done in reverse order. Let's say you're given the centripetal force information, you find velocity, then use velocity to get period, then use period to get frequency. And in fact, if you want to make some serious connections, since period is 1 over frequency, I can literally write velocity as 2 pi r frequency. You can do it either way. But here is the connection. Once you make this connection, the math is simple. This is the physics. Okay, I said this video is going to be short, and I meant it. I am ending it here. Have a good day. This is Mr. M signing off.